right. It's 12:30, so I'm going to start. Hello, everybody. Good day. Welcome to my session, Photon versus UNet. So I did a catchy title to attract a lot of people. It worked. All right. I am Chris. I'm the founder and CTO of Exit Games. And Exit Games is basically a company name to confuse our customers because we just do a single product, which is called Photon. So it's always confused. Why are you named Exit Games? We don't build games. We build multiplayer technology since quite some time now, since 2003. Back in the days, we started the company with the idea to build a backend as a service for mobile phones. I'm not sure how old you guys are, but some look like they may know the time. Nokia phones were dominating the planet, Java, Series 40, Series 60, and we built a service to do multiplayer on these phones, which had 64 kilobyte of RAM and so on. So that was quite fun time. Since about 5 years, we, as a company, we focus on Photon, which is a real-time multiplayer technology and platform. And it became quite popular. So we believed in this synchronous, well, we believed in multiplayer, obviously, since a long time. But then at some point, we said, OK, we focus on synchronous multiplayer, so really people interacting in real time. So we have more than 230,000 registered developers, mostly thanks to Unity as well, because they are so attractive and bringing so many game developers and make it affordable. And we provide a service which has already 200 million monthly active players. And we try to really run on pretty much everything, from PC to mobile, to console, to web browser, to AR and VR, and yeah, pretty much everything. So Unity decided at some point to build their own multiplayer. So we've been around in the Unity asset store since a long time, and a lot of people were using us. They had something which was called Unity Multiplayer. So the new thing, I call it UNet. And a lot of people approach us and ask, obviously, so why would I use Photon when there is UNet and so on? And I wanted to clarify that a little bit and explain not only the difference between UNet and Photon or a certain Photon product, but talk about multiplayer architectures in general. So what I will explain here in this session is not Photon specific. So it's just explaining the nuts and bolts of multiplayer architectures. So we have multiplayer products, we have messaging products, and we have on-premise. On-premise means you can run always, take our products and self-host and run it wherever you want, on your local machine, on your local network, in your company, on Amazon, whatever. But most of the multiplayer products are cloud products, which means we try to make it super easy and you can just use the stuff without thinking too much about operations. So we have 6 multiplayer products, which is becoming very confusing for a lot of developers. So why would you have 6 multiplayer products? So there are 3 categories which I differentiate. So one is, I call client-hosted, which is Bolt and Thunder. Then we have a category which I call advanced relay, which is PAN and real-time. And then a third category, which is pretty new, and I think that tech is pretty exciting and offers a lot of opportunities, and I call this deterministic. I will, in the talk, I will go into all these areas and explain basically what this category defines. And as I said, so this is Photon product, of course, but this is really independent of Photon or anything else. So you can pretty much any multiplayer technology can be categorized into these three areas. Okay, so the first one I will dive into a little bit is a client-hosted piece. And this is where UNet, so the new Unity multiplayer product is active. So what does client-hosted mean? So let's say you have a 4-player multiplayer game. I just use 4-player multiplayer because two-player multiplayer, it always tends to be a peer-to-peer discussion, which is not my point in this case. So let's say you have four players, and client-hosted means that one of the players is the so-called host, and all the other 3 guys are connecting to the host. Basically, Unity is acting in this case as a socket server. So inside your Unity app, or this one host is actively listening and is a socket server, and the other guys are connecting. So how this connection takes place is either peer-to-peer or relayed. So it doesn't really matter. But everything you want to send around to the other players needs to run through that host. So there's one thing or one architecture you can derive from this, which is instead of running the host on one of the clients, which is sometimes very convenient and cheap, let's say, you actually can run this host headless on the server. So you can host it on the server side. So here it's displayed. So in this sample, we have 3 players. Player number 1 is a host. Player number 2 is connecting to the host through a relay. Player number 3 is connecting to the host through a relay. So here, just to talk about UNet real quick and kind of, so this architecture is pretty simple. So UNet, for example, doesn't allow peer-to-peer connections as of now. It's on the roadmap, I think, but not yet. So everything you send is basically making this double hop thing. So if you want to send something to player 2, it's going like relay, host, host, relay, and so on. So it's basically quadrupling the time. So we have 2 products called Bolt and Thunder. Thunder is actually a wrapper around UNet. So it's like we took the UNet high-level API and just replaced everything. It's running on top of Photon, but you don't have to do any changes. So we are trying, as always, we are trying to take something that Unity built and try to enhance it, what we think makes sense. So in Thunder, and Bolt is a different product with a different API, but kind of similar. So in both cases, the clients try to punch to the host and establish a peer-to-peer connection. In about, I would say, 10% of the cases, this punch will not succeed. And then you actually take the relay route. So in some cases, this punch through can reduce the number of hops a package has to travel between the clients because it doesn't have to take the extra route through the relay. So here, if you do 2-player games, they are fundamentally different. So because in 2-player games, the host, so you have kind of, a lot of people talk about peer-to-peer, but this is not really peer-to-peer. It's a client-server architecture, right? So peer-to-peer would be if everybody is connected with everybody. So this is like a set. So you can take the host, which is running on the client, and run it headless. Headless means there's no UI. You skip the whole visualization part and run it on the server. So one thing that you need if you do this headless approach is you need to scale. For every game, you run an instance of Unity on the server, right? If one of the clients is a host, it's easy. I mean, the people are playing, so we have a host. But in case you want to run this guy on the server, you need to to scale these guys per server and then across servers. And there's not really a turnkey solution for this piece on the market. So there is, Amazon is building GameLift, which is going a little bit in that direction, so where you can do this. PlayFab is offering something here, or a company called Multiplay is offering services in that domain. So just talk really quick about the advantages and disadvantages. So the advantage is you have a Unity engine. So the host, the server, is a Unity engine. So you have the full model, the level, the physics. If you want to do authoritative stuff, you are in full control. So this is great, and one of the major reasons why I think a lot of developers are looking into this approach. It runs really well in disconnected scenarios. So if you are in the same wireless LAN, basically it will just run. You don't have to install servers or something like that. You can just get it going. But there are some significant disadvantages with that architecture. And the major one, especially for more than 2 players, is the so-called host migration. So let's say the host would die because he gets disconnected, it crashes, whatever. So then the whole game is basically busted. So there's no way to, well, this is what's called host migration. So you need somewhere somebody would have to take over. But since all the clients were connected to the host and the connections are dead, it's kind of pretty hard to kind of resurrect that game. So another disadvantage is if you do the headless approach, so scaling these guys on the server side, so that can get pretty expensive. And if you have the relayed version, so always running through relay to send a package, you basically always have this quadruple hop thing. So from client to relay to host, relay, other client. So that's, and for a multiplayer game where you depend on low latency, so this can be prohibitive. Here, real quick, let's say, so you have 3 solutions there. So you have the stock UNet, which you get right with Unity. So we have our enhanced UNet, which is basically enhancing what we got from UNet. And then you have the bold solution. And I did comparisons in terms of different feature sets, so the matchmaking, so they are all pretty similar. There's a little bit more filtering, which we have in our platform. So connectivity, LAN, and relay. So the punch-through is, I think, a major feature set that's interesting in general in this architecture, which UNet is missing, and we enhance it in Thunder. So in here is where we put a lot of effort into bold, is like the net code, basically the code doing the actual multiplayer, so with automatic replication and bit compression and scoping and lag compensation and stuff like that. And of course, not unimportant is the cost. So UNet is, depending on the type of game, if you are not sending a lot of traffic, UNet can be very price effective. But if you are doing a real-time game, and then real-time game means you're sending a little bit amount of traffic or a significant amount of traffic, it can get pretty expensive. Okay, so that was the client-hosted stuff I talked about. So now I go into the second category, which is the advanced relay. So the architecture is pretty simple. All clients are connected to a relay. We call it room. And the room can relay stuff, but we say advanced relay because it can do more. The room can actually store properties. It can contain authoritative logic. And it can send webhooks, so triggering HTTP calls to your own servers. So same sample, 3 players, relay room in the middle, And the client is sending stuff to the relay is sending around stuff, but the room can store properties, it can execute authoritative code. So this is, of course, you can pick either architecture, client-hosted or relay. But here is, for example, one advantage. If one of the clients is dying, it doesn't really matter because the relay is still there. And the relay room actually acts as a state bag, so you can save the state there. The advantage is it works, so there's no punch through, no craziness, basically. It runs pretty much every time, except you are behind very restrictive firewalls. You have multicast, so you send package once and the room is distributing it to everybody. You have webhooks, properties. It's super cost effective. And actually all the big, right now all the big Photon titles are using this architecture. Of course, there are disadvantages. So it doesn't work that well in local area networks because which are disconnected, let's say, which is, I think, not a super common use case, but it happens. So you would have to put a server in that scenario. And it might add a little bit of latency if you're not using a peer-to-peer connection in a two-player game. But as long as you use 3 players or more, this architecture is usually more beneficial. So the third architecture. One thing on that relay stuff. So in a relay, this can be totally dumb and just send stuff from the client around, so state basically. But this can be fully authoritative, so you can implement your whole simulation in the server, and the client is just sending input. The server is executing that input, simulating, and then sending back the state, or you can do a mix. So now, I dive into deterministic. So I have 5 minutes before I go into the questions. Deterministic architectures are on the rise. So I think this is a very interesting topic these days. So we started to look into this about 2 years ago. Games which are popular here are back in the days like real-time strategy games, StarCraft, and these guys are using these type of architectures. A very popular recent one is Supercell Clash Royale. So the core thing is in multiplayer, you can exchange state between the clients. So the clients are simulating and then replicating where are my objects and stuff like that. So deterministic architectures were completely different. So these architectures actually synchronize input. So everything you do on your keyboard, move up, jump, left, right, and so on. So you are not distributing anything what's happening on your screen. So with that input, a deterministic simulation takes the input and starts to simulate your troops or hundreds of objects or just a single player in a fighting game. It doesn't matter. The core thing is, like the name says, it needs to be deterministic. So you need to make sure that with the same input, every client is generating the same state of the simulation. And that's the biggest challenge in these architectures, especially because Unity is so convenient with all the features it has, but nothing of those features is deterministic. So Unity is pretty much in the way to build a deterministic game. Take the physics engine. You can't use a physics engine. It's not deterministic at all. And like, let's say a simple misinterpretation of collisions would result totally in different states and different clients. The whole animation system is not deterministic, so mechanism. If you use floating point numbers, it's not deterministic. It may result on different results on an iPhone than on Android than on a PC. And random numbers are not deterministic. And these deterministic solutions, which are out there, and Quantum and TrueSync are two products that we are launching, we started to replace all these non-deterministic pieces and try to enable developers to go along this way. So like I said, so each client is sending input, and you are dividing your second into all these little steps or ticks, and you are sending input around, and you need to wait for input from the other side and everything. So the advantages of deterministic simulations are it's very low bandwidth, but because you're just streaming, let's say, key presses around, so that's very slim, so great for mobile. It's very easy to implement replay. So this is how you detect, for example, Clash Royale is using a deterministic system because they have these perfect replays, very small and very fast. So this is typical for deterministic systems because you just have to replay the inputs and you have like a perfect video of your game. You don't have to store a video at all. And you can have a very high number of moving units because everything you do can result in thousands of units moving on your screen. But since you're not transferring the states of the unit, but just the input, this is very affordable. So the issues, it's very tricky to implement, so we try to tackle this with our frameworks. There's one thing, is the slow, if you have slow clients in a deterministic game, because you have to wait for input from everyone. You're executing your own input, you're waiting for the input. And if there's a slow client, he can totally destroy the game experience for everybody else because you have to wait for him to actually make the simulation worthwhile. There are solutions for this. So the server is actually can jump in and say, okay, you haven't responded for 500 milliseconds, so I'm now acting on your behalf. So this is what our server is doing, is actually punishing slow clients by injecting input for them, and they are punished. And one thing, it's difficult to have late joins. So let's say you have a game in progress and somebody wants to join after 5 minutes. It's not impossible, of course, but it's relatively difficult because there's no state. So you have to get all the input that happened in the past 5 minutes, replay it, get your simulation up to speed, and then you're able to join. So again, here's a question, why do we have so many multiplayer solutions? Because there are 3 major architectures available. And then the question, couldn't there just be one API? I think no, personally. I think there will always be multiple ways to tackle multiplayer, and that it depends on your game type, what architecture is best for you. So client-hosted, advanced relay, and deterministic. Check the watch. So I have another 5 minutes if there are questions. Are there questions at all? Okay, either I repeat it or you walk up to the microphone.
Just a quick question on the deterministic products. Do those work? Do those completely replace Unity's non-deterministic elements, or can you use those along with Unity's non-deterministic? So, for example, with physics, if I want some physics to be deterministic, but there's others that aren't important to be, simulated on all clients, can I use both?
Yeah. So you always put your core simulation into, let's say, into a very deterministic piece, which means you use like a fixed point math, you use a deterministic physics, you use, so this is pure C# basically, what you have to do there. Everything that's not, let's say you would have explosions, for example, which are not influencing your state. You can, of course, do this totally non-deterministic. So you can use a particle system or whatever. But in the end, these deterministic solutions are degrading Unity to some extent to be a pure view engine. So the simulation is becoming something which is pure raw C#, and Unity is more this simulation is actually saying, okay, Unity display this in this state. So it's wasting a lot of building blocks that Unity has and makes it great, but on the other hand, deterministic solutions won't work in this environment. So it's a pretty tough decision. It's not very easy to learn, but the beauty is once you are going down that path and your game works with this solution, multiplayer development suddenly becomes pretty easy because you have to deal with the latency, right? So you know your package travels 50 milliseconds or 200 milliseconds to the other side. So you have to deal with the latency. In deterministic solutions, you deal with the latency like in a single-player environment. And if you go down the distributed path, you have like the server simulation, you have the client simulation, and you have to bring both in sync. And we see a lot of developers actually struggling to get this done in a proper way. Yes.
Yeah, so do you know why floats were not deterministic in Unity? Is it a Unity problem? Is it a C# problem?
It's an architecture, processor architecture, right? So it's just on a Linux machine or on a Windows PC. It's just pretty far behind the comma, but still it's the little things that may a collision happen or it may not happen, and then you are totally off.
Are floats not serializable in C#?
It's not about serializable. It's about the just the result, let's say, that's slightly different on different processor architectures, so ARM or Intel. And then if you do your own, so what we did is we did fixed point math implementations, and they work the same way, so you won't see any difference. But the downside is they are not as fast as, of course, if you just use the processor implemented calculations.
With the advanced relay architecture, you can write authoritative server code. What language do you use to write that? And is it possible to use a different physics engine like bullet physics in your authoritative server using the advanced relay architecture?
Yeah, so we decided to, so in our product, the server-side logic is C# because we found Unity, it's a good fit. We run a .NET framework there, so you can use managed C++ or C# or any language in the .NET area. And of course, yeah, you can use like a bullet on the server. Right. Thanks a lot. We have a booth downstairs, so I'm happy to take discussions about your games and multiplayer in general. So thanks a lot.